I really hope that's not coming here. This is my milling machine. It's a Lagun FTV-2. It's kind of a slightly beefier Spanish-made clone of the ubiquitous Bridgeport. I bought this guy, I think about 5 years ago. It's one of those sight unseen eBay deals. I paid $500 for it. It had a Cincinnati slotting attachment on the back. I sold that attachment for $500. So I essentially got this machine for free. And I mostly got what I paid for. She's pretty clapped out, especially up here in the head. Yeah, I've never really done anything with the machine. I would like to use it, so let's see if we can dial back the sketchiness just a bit, put her back into service. Let's take a tour of this fine machine. That's a 9x48 table, same as a Bridgeport, but it's got a little more travel front to back and a little more travel up and down. I mean, it's the same layout as a Bridgeport, it's just all the castings are a little bit beefier. This one's pretty old. I think it's probably from the 80s. They haven't called it Lagun Republic for a long time. But they still make the same model. It's a little bit different. I think they have box ways here instead of dovetail ways. But the head and everything I think is identical. So the ways are pretty worn. The screws are pretty worn. The big problem though is the head. This is an R8 taper. The power feed does not work. I can't get it to engage. But the bigger problem is the belt drive up here. This machine was originally a variable speed, so it has a little bell crank here that adjusts a variable width pulley to vary the speed, just like a torque converter on a snowmobile. And at some point that must have failed, and they decided not to fix it, and they made these step pulleys. And all this motor adapter and tensioner and all this stuff up here, this is all shop made. And it works, but it's not very good. So this pulley here is pretty far out of balance. Well, I'll fire it up and you guys can see. There's really no way to fix this. I mean, not to go back the way it was to a variable speed. We're missing everything. The pulleys, the belt, the variator, the motor mounts. They've chopped big holes in the casting. Switch is gone. It's just not going to happen. But that's okay, because a couple years ago I was browsing eBay and I found a complete Lagun variable speed head. I believe it's for an FTV-2. At least I hope so. Anyway, it's pretty rough, but I think we've got enough parts between the two we can put together one decent head. It had a rough time in transit. Some of the handles are broken, the switch is broken. They just flopped it over on a pallet and crossed their fingers, which worked about as well as you might imagine. This also has an Ericsson Quick Change 30 taper, so you don't need a drawbar. It should be quite a bit more stout than an R8. I did put power to it. It works. I mean, it turns, and I think the power feed works. Anyway, we're going to crack it open, take a look at the top end. If everything's honky-dory, we'll start putting the two together. Well, we're not off to a good start. Broke my screwdriver trying to get the cover off this electrical box. So we'll try the impact driver. I don't know what happened to this thing. There we go. What a great tool. Oh, that one's loose. That one's loose and that one's missing. So we're good. Come on. I want to pull the motor off so we can check the belt, and then this conduit obviously has seen better days. Also, that's probably not good. Your bus bars are supposed to be tight, people. Jeepers. But that's why we check. What's up with this? They couldn't find the right length screws. They just stacked up a bunch of washers. I couldn't cut it off. So if you've never worked on machine tools before, this is kind of crap you run into all the time. Like all the time. They are not designed to be worked on with power tools. So you see that the bolt's too close to the motor. You can't even put the box end of a wrench on it. So you have to use the open end. The worst offender on that is British-made machine tools. There are 0 F's given. Oh, there we go. We just pulled out the threads. So that's probably getting a helicoil. Anyway, 0 F's given for the guy who has to work on them. So we gotta pull this cap off. It's got flathead cap screws that hold it on. If you've never dealt with flathead cap screws, they can be a pain. The impact driver is your friend. Don't ask me why, but all machine tools are just chock full of socket head fasteners. Which is fine, but they have their own little quirks. Okay. Oh, this is different from what I saw in the book. Oh, yeah. Got it. Well, I wonder if that'll just come out of there now. I don't know, the book I have shows a bolt in the bottom of that pulley. Negative. There goes the key. Come on. We're getting closer. There we go. So simple. You know, life is hard enough. You don't have to go making it harder by being stupid. So there is a bolt, like I said, that holds the pulley to the motor. I just didn't see it. Well, maybe it wouldn't have done us much good anyway. But don't take the snap ring out of this gizmo here. It holds that spring in place and it can easily snap your fingers. I just got lucky. So, lesson learned. Let's see if we can get that off there. There we go. Long way around the barn. So I'll have to push that back down, but I think there's a key missing now. I think we have to pull this bearing housing. The information I have seems to be for a newer machine, where the upper half of this casting is split in 2 pieces. This thing is not much fun. That doesn't seem to do what I thought it would do either. I wish I had the right book. Okay. Oh yeah, somebody's been here before. They put it in a brass shim. A couple of brass shims, trying to tighten that up. Interesting. I don't know, this thing's pretty... Oh, it's kind of tough to work on, let's put it that way. What is going on here? I bet somebody put an inch size screw. Yeah, I bet somebody put an inch size cap screw into a metric threaded hole. Or they stripped it out and went to the next size bigger. Starting to remember why I quit working on machine tools. Somebody's always been there before. Alright, so usually there's like a chain inside that drives the variator. I think that's the end of the chain. Yeah, so there's the chain. I have no idea how we're going to get that back together. Maybe we take the nameplate off and sneak in that way. So I think that this pin has to come out. That's like the pivot for the variator. It's got a couple of set screws, and I'm not having much luck getting those out. Somebody's been here before. Yeah, we're gonna have to drill that one out. Man, what a mess. Kinda wish I would have just left it alone now. Yeah, we'll try a left-handed drill bit and see. Maybe we'll get lucky. A lot of times especially with socket head fasteners, they're only case hardened. The center is pretty soft. You can drill pretty easily down through the middle of them. Do we dare try an extractor? They so rarely work. Nope. Hey, we might get lucky. Look at that. After I said all those mean things about them. Of course, we'll probably find out that we don't have to take this pin out anyway. That'll be my luck. Alright, now the only thing that's keeping us from pulling this shroud off is the brake. So that's the spindle brake. What do you think the chances are it just unthreads? Pretty good, I think. Cool. Alright. I don't know, do we have to pull this switch off? Kinda looks that way. I don't know if we can save this thing or not. Kind of like to. Okay, of course somebody's been here before. Just missing some screws. I always tell when the maintenance man's been working on it because he only puts about half the fasteners back in. What in the world do we have going on here? Lots of electrical tape. The maintenance man's other favorite toy. So it appears to just be a 3-pole drum switch. I think this whole shell should come off here now. Should come off here now. Is there a bolt still in it? There we go. About to lose the whole thing here. We got caught by an electrician. There we go. Okay. I have to find a little less sketchy way to hold that thing for reassembly. There it is. That's what we wanted to get to. The belt doesn't look too bad. And more importantly, the pulleys don't look too bad. That's good news. So there's your variator. This toothed belt down here is your back gears or your low range. Pretty similar setup to a Bridgeport. Well, we've come this far, might as well go a little further. Oh, there you go. You don't need to tighten that nut. I thought I had it moving. So that pulley won't come all the way out until we pull the brake shoes off. Of course, the screws are kind of stripped out, so somebody's been here before. They must have rebuilt this head. Maybe not even that long ago. Alright, now I'm completely lost. How do you get that thing out of there? I guess you don't. Huh. Kind of wanted to replace that belt. There we go. There's the back gears. That was a struggle. All right, the next problem is the quill does not extend, at least not smoothly. I think the power feed is sticking on. Nope, that's not it. Okay, I don't know what the problem is. I don't know, I don't like that sound. Well, I don't know where to start with that. I guess let's pull this guy off. See what's in there. Oh, obviously that lever's broken there. We're gonna have to replace that one. Oh, I wish I knew what I was doing. What can cause that thing to be stuck in, basically stuck in power feed? So that's the shifter that selects the feed rate for your power down feed. Don't see anything too nasty inside there. Nice big chunk of grease. So that's a clutch there. I still don't know what the problem is. Somehow it's still stuck. There it goes. I don't know, I don't like this. It is super hard to turn that power feed. So this little transmission goes through a forward reverse clutch, and then it turns a worm gear inside here. The worm gear drives this wheel, which is connected to this shaft, which pushes the quill down. But I don't think it should be that stiff. Wish I had the right manual that would tell me how to get this all apart. Maybe that's why it was so stiff. It's just right there. I think so. It's broken anyway. So I guess we'll go ahead and replace that. Reverse. Forward. Neutral. Yeah, so this mechanism is all jammed up too. It's just covered in this like cosmoline grease. I think we just need to get it all apart and get that crap cleaned off there. So I'm gonna see if I can get this apart, get the quill out, and then we'll kind of start over. I stripped down the old head and I harvested the good parts, which are mostly to do with the power feed. Hopefully somebody remembers where all this stuff goes. You might want to sit down for this. I found some problems. I know it's hard to believe. Let's start with the good. The spindle is good. The bearings feel excellent. I have no plans on replacing those. The fit of the quill in the housing is nice and tight. The fit of the spline onto the other way, onto the back gear is nice and tight. That can be a real problem. They get sloppy and then you get chatter issues, and there's no way to fix that other than replacing this and this. The pulleys also look really good. That's still the original anodizing. Wee bit of corrosion there, but no wear. A couple minor problems. We need some helicoils in this housing. The casting's just like Swiss cheese. This little guy here is the reverse feed trip lever. It was missing in this head and it was broken in the other head. So we need a new one of those. The brake cam has been welded up, so we'll throw in the one from the other machine. A couple of other parts related to the feed mechanism that we're going to swap out from the other head. But the major problem is with this shaft. I knew when I saw these homemade shims we were going to find problems. Short version, we have wear on the bearing journal at the end of this shaft. It's about 1/1000th of an inch, 0.025 millimeters, which isn't a lot, but when you're talking about bearings, it's kind of a lot. Long story longer, here's what I think is going on. This gizmo here is the variator. It has this thing that attaches basically to this pulley, and you turn the crank, it moves this thing up and down, moves the pulley up and down, and changes the belt ratio. Somebody's been here before and they've tried to fix this. You see they brazed up this journal here where the top bearing attaches, and that's actually fine. It's pretty good repair. The diameter is right on. Somebody's been into this thing before though. You can see the remnants of some Loctite. So they tried to Loctite that bearing into this aluminum housing. That's not ideal, but that's not the end of the world. This guy right here is the pulley for this toothed belt. That's part of your back gear system. So in direct drive, this gear right here slides up and that dog clutch engages, and you have direct drive from this pulley right into the spindle. When it's in back gear, this gear slides down. Please don't fall off. It meshes with this gear right here, and then that gear has the large diameter timing pulley that goes on this belt, so it's a double reduction. What I think is happening is when you're in direct drive, which is probably most of the time, you don't use back gears that often, this gear slides up and engages the dog clutch, and there's a bunch of springs that hold that gear up and hold that dog clutch engaged. And when that happens, it takes away the preload on the bearings, so that there's a bearing at the top and the bottom. They should be squeezed a little bit, and that helps, keep everything where it should be, keep some tension on the bearings. If that preload goes away, then this thing here can start to spin, or the bearing can start to spin on the shaft. And I believe both of those things have happened. And actually, if you look at this guard here, you can see it's all chowdered up there, it's all chowdered up there, and it's all chowdered up on the end of the spline. So all that stuff's been working against each other, which really isn't that big of a deal, but the problem is this whole shaft is starting to move down, and you can see it's actually contacted the brake shoes with these webs on the bottom side of the pulley. Even worse, this is the snap ring that sits on top of this bearing, and you can see the guard has actually come down so far that it's worn through the snap ring. It's about halfway through. So that's a problem. And unfortunately, there's no good way to fix it. So I have the shaft out of the other machine. It's also worn. So this one is worn 1/1000th at the bottom and it's good at the top. This one is worn 1/1000th at the top and it's good at the bottom. But it's also kind of messed up here where the variator pulley slides. It's supposed to be chrome plated, should be nice and smooth. This one's all pitted up. They had that step pulley pressed over it. So I don't know if we can use that. A new shaft from Lagun is $1,500, which is, it is what it is, but that's a lot of money to put into a clapped out old manual milling machine. As far as building up this end here, that's not so easy because the teeth here are hard as a $9 jawbreaker. You cannot touch them with a file, which is good for wear, but it's bad for trying to fix it. So we can't come in here and do our maintenance man routine and try to dimple that or knurl it and build up the surface. We can't braze it or spray weld it because we're going to lose the heat treat. I mean, the only thing we could really do is hard turn it and then make a sleeve and press over it. But if we do that, we're going to lose some of the tooth structure for that dog clutch. So I don't know what to do. There is no good way. We have the guard out of the other machine. It's in pretty good shape, so we could slap that in. But this shoulder is worn. It's moved back a fair amount, 100 thousandths probably, which is what caused that pulley to come down. So yeah, I'm still thinking about how to try to fix that. I want to do something, but I just don't know what it's going to be. Must be a common problem because I'm pretty sure this shaft has been repaired once before and it needs to be repaired again. This shaft's been repaired at least once and needs to be repaired again. Yeah, it's just a crappy design. Bridgeport does it differently. They have the bearing up here on the other side of the pulley. So the other problem too is that this has to be a sliding fit onto the bearing because otherwise you can't get it apart. The timing belt is here. You cannot remove the timing belt unless you remove this shaft. So all this stuff has to be able to slide off the end. We can't use Loctite or anything like that. So yeah, we're kind of in a real lurch here. I got to think about what I want to do. We got to do something though, because I don't like that. I don't want to just put it back together with that wear, because it'll just get worse. Boy, the more I look, the more I don't like either one of these. I guess we're going to have to choose the lesser of two evils. But that is not an easy choice. We're worn here and we're worn here. This one's been repaired here. This one's been repaired here and here. I'm almost positive that's been spray welded. And then in this whole section right here where the variable pulley slides up and down, that's also been spray welded pretty poorly because they got a big chunk missing here, big chunk missing over here. But this end is good. You know, and then opposite on this one, the chrome here is excellent. This journal's good, but we're worn down here. Also, this one's got a couple of egged out holes in it. So I don't know. I mean, we could fix that journal, but I really don't want to fix something that's already been spray welded once before. That's just asking for trouble. And then this, you know, that's not ideal. So I think what we're going to do, we're going to try to fix this original shaft. I've got a sleeve here. We're going to turn this down. We'll press this sleeve on. And it's only about 40 thousandths smaller, so we're not going to lose a whole lot of these teeth. And then it should be large enough that we can also kind of build up this shoulder, because this shoulder is worn and this journal is worn. I guess let's try it. Worst case scenario, we'll go back to plan B. Remember, it's hard. We should be able to cut it with carbide. The problem is it's only hard on the very end. and it doesn't cut as deep there. Not sure what to do about that. Okay, so we're right on the money there. I think we're gonna have to do it by polishing. Let's try it. Always fun. I put a little bit of Loctite on there. I don't know if it really matters. Makes me feel good. There's something super satisfying about press fits and close fits. Look at that. It's even harder to get back off. Got to do it like a Band-Aid. Rip it off. Oh, so close. There it is. I cut the teeth in with a file. I thought it would open up once I cut those sections out, but it didn't really seem to. Cool. I'm going to cut these ones with the Dremel or something. They're a little too tight for a file. I don't want to toot my own horn, but if you didn't know that was a sleeve, I don't think you could ever tell. Got a nice fit there. It could be a little tighter. I thought about trying to pin this flange to the shaft some way, but it shouldn't matter. Come on. There it is. So all that really matters is that the inner race of the bearing doesn't spin on the shaft. And we're good there. If we get the preload right, if we get enough preload between the top bearing and the bottom bearing, it should hold everything in place. We shouldn't have a problem. So I think we're good. Unless I'm missing something, we should be able to start putting this back together.